The other half of this section is probably more like the other third of this section, involves solving systems of inequalities by graphing that aren't linear. So a linear system of inequalities is just equations that are lines, okay, linear equations or linear inequalities. That's what we dealt with in the first part of this section. Now, it doesn't matter if it's a line or an absolute value function like this one or anything else. It can be anything. We still wind up graphing them the same way. So first, put it in what we would call slope-intercept form. Basically, solve for y first. Once y is by itself, then you can use that shortcut that I taught you. And then you just graph like we've been graphing other things using your transformations. If you don't remember how to use the transformations, just set up a table of values, and that will get you the same answer as well. So y is less than or equal to positive 3. What kind of line are we talking about here? That's a horizontal line that goes through 3. So I go onto my grid, I mark that, and I don't need any other dots because I know that's a horizontal line. But I do need to remember, is this going to be a solid line or a dotted line? This isn't solid, a solid line. What else do I need to do here? In this case, with less than or equal to 3, am I going to be above or below? Below. So now I mark them, and I don't shade. That tells me I'm shading below. Okay, for the second one, what kind of a graph am I going to have there? Yeah, this is an absolute value inequality, so it's going to look like a V, but then we're going to have to shade that as well. So I have y is greater than or equal to x minus 1. What happens to my V? Does it get moved down 1, up 1, left 1, or right 1? We'll do press your luck style. It's one of the 4. You've guessed 2 out of the 4. We need to remember our transformations. Y equals a absolute value x minus h plus k. That is, inside the absolute value, h controls horizontal transformations, left or right. We're supposed to see the minus sign. We do see the minus sign, so this is going to move which way? To the right. The vertex moves over 1 to the right. We did not dilate this. We did not reflect it. So this is your standard absolute value function now. So slope of 1, slope of negative 1. Now, solid or dotted? Solid. And which way will we shade? Shade above. So on my absolute value graph, I'm going to draw little arrows up. And then just like before in the first part of this section, we want to only shade the region that gets hit by both shadings. In this case, that's going to be the little wedge of space right here. So that's what we shade. And we could call that a feasible region as well, just like we did in those last problems that we were working on. But that there is the answer. You could have this be your answer. You could have this be your answer, or this. Any one of these regions, this whole thing here would be a region. That could be your answer. Any one of these regions is a possibility for your final answer. So for the second one, what is the graph of that top inequality going to look like? It'll be a dotted line. Yeah, that's a linear inequality, so you'll see a line. And then the bottom one will look like a what? A solid V. That's an absolute value inequality, so the graph will look like a V. And then we have to figure out where the shading is, okay? So you need to recognize linear. You need to recognize absolute value. And I could throw parabolas at you as well, and it's the same idea. So y is less than negative 1/3 x plus 1. That's going to be a line. So I go to my y-intercept of 1, and then I have a slope of negative 1/3. So down 1, right 3, down 1, right 3. Reverse it, up 1, left 3, up 1, left 3. And we said this line will be dotted. Line up your ruler very carefully. Remember, we are in the realm of problems that requires very good graphing. There you go. Which way am I shading? Below. That says less than means shade below. Okay, now I have an absolute value inequality. First I want to figure out what the vertex is. I can use transformations to do that. Where's the vertex at? Right 1 and then down 2. That's right. Right 1 from this, down 2 from this, right 1, down 2, there it is. Did I dilate this? Did I reflect it? No, so it's just going to be a standard V. So up 1, right 1, a slope of 1, and then a slope of -1. We're going to draw that in with what? Solid or dotted lines? Solid. Again, very carefully. And which way am I shading this time? Greater than says shade above, so I do this. And the region that got hit twice was what region? The middle of the triangle here. So that's what I'll shade. Here's a quick question for you before we call it quits for this section. If I pick any ordered pair within that shaded region, it is a solution to the system of inequalities. But what if I pick an ordered pair that's exactly on this dotted line right here? Then it is not a solution to the inequality, to the system of inequalities. It would wind up being a solution for the absolute value inequality, but it will not be a solution for the linear inequality, which means it will not be a solution for the system. That's what that dotted boundary line means. You can't actually be on that dotted boundary. So that does it for the section. Got a whole bunch of problems that you can do now. Go ahead.